All right, let's dive in. Today, we're going to crack open one of the most powerful tools in any financial analyst's toolkit. I'm talking about the normal distribution. It's this fundamental concept that helps us answer some of the biggest, most pressing questions in finance.
So picture this. The market takes a 5% nosedive in a single day. Your gut clenches, right? You're asking yourself, is this just a random blip, a bit of market noise? Or is this a warning shot, a signal that a real crisis might be brewing? This is exactly the kind of high-stakes question that financial analysts have to wrestle with. And believe it or not, there's actually a structured, almost mathematical way to start answering that question. Yep, finance has a specific tool designed to help us separate the everyday from the truly extraordinary. It all starts by connecting three huge concepts: the risk you're taking, the returns you hope to get, and this simple, elegant shape you've probably seen before, the bell curve. And here it is, the normal distribution. You see this beautiful bell shape everywhere, seriously, from nature to finance. And that's because it does a fantastic job of describing how data points, like, say, daily stock returns, tend to bunch up around an average. Most days are kind of average, right? And the further you get from that middle, the fewer and fewer results you see. So, if we want to put this amazing tool to work, we've got to understand what makes it tick. And honestly, it all comes down to just two key numbers. And what's so great here is how we can translate this abstract math into something with real financial meaning. The first number, the mean, you'll see it as the Greek letter mu, is just your expected outcome. Simple. Think of it as the average daily return. But the second number, standard deviation, or sigma, this is where it gets really interesting. This is our measure for risk, for volatility. It tells us just how wild the price swings are. A wide, flat curve, that means a big standard deviation and some seriously wild price swings. A tall, skinny curve, much more stable. Okay, so sigma tells us the risk for one asset. But how do we compare the risk of two totally different things, like a high-flying tech stock and a boring old utility company? For that, we need a kind of universal adapter. And in statistics, we call that the z-score. And this quote just perfectly captures its power. The z-score is a standardized number. It can take any data point from any normal distribution, and it tells you exactly how many units of risk, how many standard deviations it is away from its own average. It puts everything on the exact same scale. It's brilliant. And calculating it, it's a super simple two-step process. First, you just find the raw distance between your data point and the average. Then you just divide that distance by the standard deviation to see how many risk units that represents. That's it. That's your z-score. Now, once you have z-scores, you can unlock one of the most powerful rules of thumb in all of statistics. It's often called the empirical rule, but you'll probably remember it as the 68-95-99.7 rule. You should really think of this as your quick and dirty guide for spotting outliers. It gives you an instant framework for understanding what's a totally normal, everyday event and what's a rare, significant one that you need to pay attention to. First up, 68%. This rule tells us that for any normal distribution, about 68% of everything that happens will fall within just one standard deviation of the average. This is the zone of the ordinary, the totally common, everyday market movements. Okay, now let's widen that range. If you go out to 2 standard deviations from the mean, you suddenly capture a full 95% of all the outcomes. So anything happening outside this range is starting to get pretty noteworthy. We're talking about something that has only about a 1 in 20 chance of happening on any given day. And finally, if we go out to 3 standard deviations, you capture pretty much everything, 99.7% of all the data points. An event outside of this range is extremely rare. These are your true outliers, the things that happen only a few times out of 1,000. All right, enough theory. Let's get our hands dirty and make this stuff concrete. We're going to put these tools to work on a real-world financial problem. So here's our scenario. We've got a stock that, on an average day, returns about 0.5%, and it has a standard deviation, our risk level, of 2%. But today, it jumped 5%. The question is simple. Should we be surprised? Was this an unusual day? We can solve this with a z-score. It's easy. First, the distance from the mean is 5% minus the average of 0.5%, which gives us 4.5%. Then we measure that in standard deviations. 4.5% divided by our 2% risk unit, and that gives us a z-score of 2.25. So, what's the verdict? Well, a z-score of 2.25 is more than 2 standard deviations away from the average. And if you remember our 68, 95, 99.7 rule, that means this event happened outside the range where 95% of all the returns usually happen. So, yeah, absolutely. This was a statistically unusual day for this stop. Now, this is all great in a perfect theoretical world. But we all know the market is not a textbook. It's messy. So how well does our perfect little bell curve actually stack up against the chaotic reality of the stock market? Let's look at the actual data for the S&P 500. Within 2 standard deviations, wow, the model is remarkably close. It predicts 95%, and in reality, it was about 96%. Pretty good. But look at that 3 standard deviation range. The model says 99.7% of all days should be in that range. The reality? Only about 98.4%. And that gap tells us something incredibly important. That gap means that real markets have what analysts call fat tails. While the normal distribution is a fantastic guide for what happens most of the time, its big weakness is that it underestimates just how often the really wild extreme market moves happen, both the huge crashes and the massive rallies. Those once-in-a-lifetime events, yeah, they happen a little more often than our perfect model suggests. And this brings us to this famous quote in statistics from George Box. The normal distribution, just like any model, is a simplification of reality. It is not perfect. By definition, it's wrong in the details. But for understanding risk and probability on a day-to-day basis, it is unbelievably useful. So we're going to end with a critical question, one that every analyst has to think about. Knowing that real markets have these fat tails, that extreme events are more common than the model predicts, how do you use this powerful tool while also accounting for its biggest blind spot? Answering that, well, that's the difference between just knowing the theory and being a smart real-world risk manager.